This is the notebook we are going to cover in this tutorial. The notebook is divided into two parts. In the first part, we will import libraries, read and check and visualize the data, whereas in the second part, we will build a decision tree model, also evaluate it using classification metrics. In addition, we will highlight most important features in the classification and finally visualize the tree structure. In the end, I will provide the exercise in order to practice by yourself. Because I store the data in the Google Drive, first step is to connect our Google Drive. We can import Drive module from Google package. Let's run this code. We can start our first part by importing libraries such as pandas, seaborn, numpy, matplotlib. Also from scikit-learn library, we import decision tree classifier class and the following functions. We will see later why we need these functions and classes. Let's read the data by writing pd read csv, and we will pass the following parameters such as data path, which we can find here, header equals to none because the data does not contain any header, and separation equals to comma. I also shuffle the data in order to be more representative, and let's run this code. As you can see, the data contains 61 features. First 60 features are input features, and the last feature is output feature. Because the data frame columns are numbers, it's a good practice to assign textual names. In order to do that, let's write data columns and we assign new feature names. Let's run this code. Also, as you notice, output feature contains textual names. However, machine learning models work on numerical data. Therefore, I replace R with 0 and M with 1. Let's run this code and visualize the data. Now, feature values are numbers. Next step is to check and understand the data. We write data point is now point sum. However, we cannot visualize all the feature values here. We can only visualize the values of these pandas series object by extending our code with point values. You might notice that none of the features have any missing values, so we are good. We can also check the data types, just writing data point data types. We cannot visualize all the feature data types. Again, we just write data point data types values. Alright, all the data types are numbers. Before we start building model, one more step is to visualize the data and see the correlation between features. We can do it by pair plot function. We can pass the following parameters, such as data, subset of the features, and output feature as hue. Let's wait a few seconds. Great. Here, orange dots represent mine and blue dots represent rock. However, we cannot see clear distinction and separation between these classes. We can visualize other subset of the features, just doing the same. Alright. Here, for example, the last feature, the feature 10, with the correlation with other features, we can see the separation of these two classes. And let's hope that this feature is more important for our prediction. It's a good practice to visualize the target feature distribution as well. We can do data and the name of the last feature, point value counts. We see that there is 111 ones and 97 zeros. We can just do visualization of this information here. Alright, we have finished the first part of the notebook. Now it's time to have hands-on practice on the decision tree classification model. We visualize the data again, and we separate our input and output features. We write data point drop, which drops the last feature, output feature, and keeps all other features. Let's visualize input and output features. It's always a good practice to separate the data into two parts. We train the model on some part of the data and evaluate our model or on another part of the data called test set. In order to do that, we use train test split function and we pass data f, which is our input feature, labels our output feature. We assign the size of the test and random state equals to 42 in order to be reproducible split every time we run the code. Let's run this code. As you can see, we have 166 training data points and 42 data points for testing. Now we instantiate our decision tree classification model and we create DT object. We train the model using training features and training outputs. After that, we predict on unseen data, which is test data. This is the prediction which was generated on test data, and the size of this prediction is just 42. We can see the ground truth labels here. Okay, as we train our model, we should always evaluate it. For classification tasks, confusion matrix is a good visualization to see how our model performs. We can use plot confusion matrix function from Sklearn library to do that. We pass our classifier object, test input and output features, and let's plot. This diagonal is correct prediction and second diagonal is errors. From confusion matrix, we can calculate accuracy, precision, and recall. However, in this case, I use built-in functions from Sklearn library again. All right. Accuracy of our model is 69, precision is 68, and recall is 77. From this scores, we can see that our model works. These are not good scores, however, it's better than 0.5, which is just a random prediction. Sklearn library also have good function, which is called classification report, which visualize and prints all other classification matrices, such as precision, recall, F1 score, support. In this case, it's the same as here. We can see what are F1 score and support in the later videos. As we evaluated our model, we can do interpretation as well, in order to find out which is the most important features in the classification. We can do it by writing dt point feature importance, which results importance scores of all the input features. We can visualize it by bar plot function from Seaborn library. We can pass column names in the x-axis and associated scores in y-axis. As you can see, the most important feature is feature 10, followed by feature 15, feature 18, etc. There are a lot of features which did not take participation in prediction. Now I will show you cool visualization of tree structure of our classifier using GraphViz library. We can create a tree from tree class and we pass our classifier, feature names, output class names, and we can visualize it. Cool. As you can see in this tree, the first node is a root node with the splitting criteria feature 10 is less than 0.174, and these nodes are decision nodes which are splitted further, and the last nodes, these ones, are leaf nodes which are not splitted anymore. You can see the previous video if you want to understand how this tree is created and how does the model chooses the splitting criteria. Here is the exercise that you can do in order to practice. This is the dataset of wine quality. You can download it from this link and I will just visualize it. These features are input features and the last feature is output feature, which denotes the quality of the wine. You can build a classification model using decision tree. You can calculate accuracy score and print confusion matrix. And you can share your result in our GitHub discussion section or our Discord community channel. If you are stuck on something, you can post the question at any time. It is the end of the tutorial. I hope you liked it. To sum up, we have discussed practical part of decision tree classifier. We built a classification model which evaluated whether an object was a mine or a rock. Don't worry, if you don't understand all the functions of pandas and scikit-learn libraries, that's how we learn by doing. In the next tutorial, we will discuss theory behind the popular machine learning classification algorithm k-nearest neighbors. Make sure you subscribe in order not to miss it. See you in the next video.